let's have a look at the model encoder. First we need a model. I use the standard model, this, and we see here we have this program or this crypto structure where in the starting state we have not P and not Q, and you can think of those two variables as resources which we should not access simultaneously. So if we access P and Q simultaneously, we run into a deadlock in our program. So we start at not P and not Q and want to see if it's possible to reach a deadlock. For this, we can go to the Encode a Model tab. First of all, let's delete the traces. We will talk about them after that. And we see here that the trace is missing. It gives you a hint, but everything still works. So let's just generate one step because it's easier to follow. And we see here if we're at not P and not Q at time step 0, this implies that we are either at not P and Q, which is this state at step 1, or P and not Q, which is this state. And if we want to check if we can reach any state, we need to log the variables to that, because the encoding also generates state encodings for every state. So we need to log the variables either by typing them out with and not P0 and not Q0, and the final states we want to reach or want to check that this is not possible to reach, not P1 and P1 and Q1. We click on check and we see that the formula we entered is unsatisfiable. This is because in one step we cannot possibly reach this state if we're starting here, because it takes 2 steps. So let's generate 2 steps, and also this is what would be it. But let's use the compact encoding. This is the same, just a different notation. And let's add a start state in S1 and an end state in S4, which is this one. You can also make the same state a start and end state, then it will turn a mix of green and blue, but we just want to keep it as an end state right here. So let's encode this, and we are seeing here that the start state and the end state have already been encoded for us. So we can click check, and now we see it works. We see that we start at not P0, not Q0 as we wanted. We go over P1, not Q1, which is this state, and we end up in P2 and not Q2, in the deadlock state that we wanted to avoid. So now we know that this program or this crypto structure can definitely end up in the state we did not want. We can also use limbool to verify our model or generate a formula for limbool. This is done here. It's not in here since we cannot use check on it. So we can either copy it, or we can just click the link, check in limbool. It will open a new tab with the check automatically done. Or if we want to copy it manually, we can just double click into this field and it says copied solution to clipboard. And then we can go in here and paste the solution using Ctrl V, or with right click and paste. Right.